So, welcome to another episode of BetaTalk, and I would like to thank my guild patrons. They are Primary Pro, the outside pipe lagging system, and I've just noticed today they're part of World Skills. That's fantastic news. I've also got UK, Cast Rads and UK Radiators, and also the Wolsey's Group Renewable Centres. So, thank you very much to my guild patrons. So today it's budget day. I know nothing about politics, so I don't know if I want to go anywhere near the subject. I do know a little bit about heat pumps. And today on the show, heat pumps. It's the Heat Pumps Association's annual event today, also at the British Library. And unfortunately, I couldn't go. I was invited. I couldn't go. I'm recovering from surgery. Nothing major. So no one worry. But wish everyone well. You may be listening to this on the way home because I'll probably try and get it out today. Today I'm joined by John Ewbank, and he will explain exactly who he is in a minute, what he does, why he does it. John and I started chatting a few years ago, I think, John, didn't we? And he has a very good, astute interest in air to air, which is obviously, I'm no great engineer at all. But my family's been involved with air to air systems for a long, long time. In fact, actually, John's the only person I know in sort of my whole vast network of LinkedIn and social media that's ever spoke to my cousin. You probably don't know that. So John has actually had a conversation with my cousin who's been in this game. So John, thank you for coming on the show. We're going to talk about air to air for some reason. Well, you're going to tell us why you've got this passion about air to air. You've been studying it. You're now working with that wonderful team at Nesta. You're doing some bits and pieces where you're looking into air to air. So yeah, tell us all about yourself. What's your background, and why did you get into heat pumps, particularly air to air stuff?
So thank you. I suppose my background is I have a degree in civil engineering and a degree in mechanical engineering. So I do come from sort of the more mathematical side of a lot of things. In terms of heat pumps and getting into air to air, I guess like a lot of people who've moved into this space, we've seen interesting things from the likes of Simon from Urban Plumbers, Adam Chapman from Heat Geek, and especially the guys from Open Energy Monitor, Trystan and Glyn, because you've got the data side of it from Open Energy Monitor, so it sort of draws you in and you get interested. So I guess that's how I gradually have moved to this space. And air to air specifically has come about because I was trying to solve a problem for a friend of mine who essentially has electric resistive radiators. Obviously, everyone had been talking or is still talking about air to water and saying, oh, air to water, is what you want for heating. It's the perfect solution. But we got some quotes and they were, as you would expect, in a new system, retrofitting it to an older house, new radiators, new pipes, massive. We're talking, I think it was £15,000 after the grant. So it wasn't a goer. From that, I thought, right, okay, let's research the options. Air to air came out as a logical solution. But in researching air to air, what I found was the information that's out there is not put out in a way which is particularly understandable for other people. So, for example, you can look at a spec sheet for an air to air heat pump and learn pretty much nothing. You get some rough Scott figures, some COP figures, you get some dimensions of the unit, but you don't understand what those really relate to. And it turns out they don't really relate to a lot of things. So in my conversations with various people, I found that the Scott figures are sort of fabricated in a way. So they're done in the testing environment, but the manufacturers can go into the testing environment. They can change the fan speeds and the compressor speeds based on the load, the optimal load conditions at any temperature. And that might not be what the unit will naturally perform in your house. So basically, it's been looking through these problems I have found while trying to choose a unit. And then from speaking with Trystan and Claire at Open Energy Monitor, Trystan sent me out some kit to try and estimate the SCOP of the unit, which I did with mass flow calculations, so looking at the temperature above and below the unit, and then working out the volume of air that's moving through and the heat that is delivered based on the temperature change. And if you work out the volume of flow, you can work out the mass, temperature mass. Can't remember the specific term right now. So yeah, it's been a progression of that, and now I'm sort of iterating, trying to make a more general method to solve COP for heat pumps so people can measure them. And through all of this stuff, through this research, I ended up I sent a message to Andrew Sissons at Nesta saying, look, we're monitoring these units. We're trying to understand what the actual real world coefficient of performance is for them. How efficient are they? And then from those conversations, Nesta sort of said, well, we've actually got our own questions, which are things like, how much do they cost to install? What kind of homes are they suitable for? How do homeowners actually like them? So this has been a progression of that work and my own personal interest.
Well, for me, it's fascinating because I'm going to put you on a pedestal a bit. I was with my cousin when you had that conversation with him, and that conversation got to a point where I think, crikey, this is all going over my head, and I could tell that in a very short space of time, you've accumulated a lot of knowledge around air-to-air. Now, I know people that have been in the air-to-air game because it's, as you would know, it's mainly a commercial sector. And as I inculcate all the time on social media, we have the largest commercial sector in Europe. So heat pumps are everywhere in this country. But I could tell very quickly you have really dived. I mean, you obviously got a very good analyst. You like analysis and all this kind of stuff. And you've obviously, Andrew Sissons actually put out a lovely post recently, didn't he, about air to air and about how it's going to be in part, maybe part of the bus. You've watched all the politics today, I haven't, so we may talk about that. But I could tell very quickly you really dived into this, and you've mentioned Trystan and Glyn there. You're fascinating people. I've got no idea why they haven't won an award yet. I've seen people win awards for decades in this industry. Well, not half. Some of them probably don't even deserve them. But these two have done some amazing things, and then it inspires people like you who love data, who love analysing data, who are hands-on. And so you mentioned something there about, didn't you? So you will know there's something called nominal size. And also with air-to-air, you kind of got these two things going on. You've got cooling, you've got heating. And obviously, usually heating is going to be a bit of a bigger thing because when you're heating into a space, you've got the heat from the compressor, the fan motor and things like that. Obviously, when you're cooling, you're removing heat and chucking it outside. So there's kind of these two numbers. Most sort of commercial AC engineers are going to sort of reference what they call a nominal size. But as you sort of discovered, what does that always mean? They are laboratory test things. Now, when you were chatting to my cousin, and what I'm going to say as well, you do some research, you've been chatting to people that have got this stuff. And you and I know, we've seen people on social media saying, oh, it's not good. It dries your skin, rah, rah, rah. Now, it's no different to air to water. If you design it wrong, you're going to get problems. It's not going to be comfortable. But, well-designed systems. So, like I said on a post today, the Heat Pump Association at the British Library, the British Library houses some of the most important documents on the planet, things like the Magna Carta, the only surviving script of Beowulf is there. These things will be temperature controlled. And there's a lovely little heat pump system in there now that's actually being kind of powered by this solar PVT system on the roof. But you'll often find rare parchment stuff is going to be controlled in what they call close control air conditioning. Very, very, very strict parameters on humidity and temperature. Same as surgeries. I've just come out of surgery. That's going to be controlled with very strict parameters on humidity. So there are places where you have to get this stuff right. Obviously, not everywhere it is being installed correctly, and that's in the commercial sector as well. And as we're probably worried about some of us engineers, if we do go into domestic, and I've been one of the leading advocates of that, there is a potential it's going to go in quite, not always optimum. And so just that you spoke to people that have this stuff. Now, I think generally there's a positive vibe and the people you spoke to quite like it. Am I right?
Yeah, generally there's a massive positive vibe. So So I'm writing this report. I have to be aware of the things that can go wrong, and that's going to come into the report. But I also have to be aware of what everyone has told me. So I've interviewed these homeowners, and most of them have said, I love it. It's fantastic. It's way better than my hydronic system. So they've not come from electric resistive radiators. They've had a gas system and they've replaced it with air to air, and their experience has been very positive. However, and this is a big however, and it's sort of, it might be getting lost a bit. The initial feeling of air to air for quite a few people is not as positive because they tend to run it like a gas boiler. So having it intermittently heat, so you turn it on when you're in the room, is you hear a lot of people talking about that on LinkedIn and things like that. So they'll say, oh no, you can just run your air to air like this. You don't need to worry about heating up the walls. But if you run it like a normal heat pump, it is a more pleasant experience. And that's because, you know, your whole room is heating up. So your floors are heating up, your walls are heating up, all your furnishings are heating up, and you're getting that radiant heat back from them. So you're not coming into a cold room which feels cold. I have had some homeowners report issues with certain units. So there is a well-known issue with air-to-air heating, which is induced by the stack effect, which is essentially that warm air rises. Because the sensor for when these units switch off is often on the air intake of the unit. If your hot air rises to the top of the room, your unit will pull in that warm air, and as it pulls it in, it will say, oh, this is hot. I've reached temperature. I'm going to turn off. Now, this isn't universal, and it doesn't happen on all units, and that's kind of the weird thing. I don't have a good handle on, like, you know, the proportion of units this happens on, but I do know it happens on some units, and it's a real problem. One unit it doesn't really happen on are things like the Daikin Stylish, for some reason, the Mitsubishi Electric LN, MSZ range. And I've not interviewed anyone with Fujitsu units. I know, so maybe it's better to talk about the mitigation methods of this, right? So you have this problem, but there are, on some units, but there are mitigation strategies, which are, you can get external thermostats. So you can essentially have these IR, as I say, so what I mean is, you can have an external thermostat that replaces your remote control. So most of these units have a remote control, and this external thermostat will mimic the remote control, but it records this temperature sensor where you place the temperature where you place this external thermostat, rather than on the air intake stream. And a lot of people report much better comfort after they've done that. Certain units, like the Medea units, have what's called follow me function. They have a thermostat within the remote, so you can put the remote wherever you want. There might be other solutions that come out in the future, but fundamentally, there are workarounds for this. So that's the comfort side of it. And people love it, apart from the people who have a bad unit and then they don't like it. There are unanswered questions, though. One of the unanswered questions is to do with fan speed and efficiency. Fundamentally, like, when you increase your fan speed on your unit, you're lowering the condensing temperature of the refrigerant. The lower the condensing temperature of the refrigerant, generally, there are limits to this, but in general, that's going to be the case. However, most people I spoke to would say, oh yeah, the unit's dead quiet. I don't worry about the noise at all, but they'd have it on fan speed 1 or 2. Now, I don't know the COP penalty or the efficiency penalty for running on low fan speeds. I suspect for most of the year, it's virtually nothing. So your unit will still be very efficient for, I don't know, 70% of the year, 80% of the year when you're running in heating. But there will be very cold days where it will be quite a bit less efficient if you're just running it on those low fan speeds. But this is a project I'm working on at the moment to try and quantify, as you've seen with lots of the temperature sensors I've been trying to fit on my unit. So all in all, yeah, it works. There's no doubt it works. I think actually another point to say is people talk about this being a different type of heat to radiators, but it's not a different type of heat to radiators, because radiators aren't radiators, they're convectors, right? 80% of the heat off your radiator is coming out
Oh,
heat,
John,
not as radiation. Unless the rate, like,
we're cutting in and out. If you turn your camera off, you can still, or one of us turns the camera off, we might get back because I'm cutting in and out on this side.
okay.
Do you want to cut yours off and see if that works? And you can still see me. I don't know. You might want to
Yeah.
see, you might not want to see. So going back to that point, radiators. Yeah, I mean, radiators do sort of two things. They convect and they radiate, and it's not a linear relationship. As you drop the temperature in a radiator, it radiates more. But
Convex more.
this comfort thing is interesting because I think when I've talked about air to air on social media, you get you get a bit of kickback, and the kickback will come from the entities that sell air to water, unfortunately. Well, not always, but you'll get a kickback. I mean, maybe people are thinking about, they've been in a hotel room or they've been in an office where they've felt quite uncomfortable. And again, it's set up. Unfortunately, even in the commercial world, some of this stuff doesn't get designed, installed, and commissioned properly. No different to air to water. That's why you need good engineers. But did you haven't got one in your own place, have you? Or it's your friend that's got one? Am I right? Is this where you're doing all your testing?
Yeah, it's a friend. It's my friend that's got one. I don't want people to get the wrong impression. I do think that a good wet system will.
Yeah.
So if you've got a well-performing wet radiator system, it will be better in heating than an air-to-air system, just because you don't have to worry about airflow as much. So
Yes.
if you've got a forced convection and you're blowing air around, you will get noise. There's not really any way around it. This is something I'm also trying to figure out, is whether or not you're better. Well, I sort of know the answer, but there are cost implications to doing it. So if you've got a large downstairs room, and let's say your heat loss on this downstairs room is 4 kilowatts at 0 degrees C, you could get away with having a 5 kilowatt indoor unit, but you'd be better off for comfort having two 3 kilowatt units that would balance the load down, or two 2 kilowatt units, just because the fans would have to work less hard, and because so it'd be less noisy. So there are comfort penalties, and also there's comfort penalty from blowing air down. So if you've got a high wall mounted unit and you're blowing air down, you have to be aware of where you're putting your furniture. If you put high furniture under it, it's going to stratify. It's not going to reach the floor. It's not going to mix the cold air and the warm air. If you've got clear path to the floor, it works much better. But I guess thinking about a system, do you want two systems? Do you have a cooling need? Because if you have a cooling need, then it might make a lot more economic sense to sort of spend more money and have the air-to-air system rather than, spend more money and have the air-to-air system, because your grant's going to be smaller, rather than getting the air-to-water and having duplicate systems. But there are so many variables. There's not really a good answer.
Yeah, I want to sort of emphasise that point. Wet systems are brilliant. A good design, they're absolutely brilliant, absolutely comfortable, as we know, and as a lot of consumers out there know as well. And you're very, very right to put this thing about air movement is very, very important. I mean, you've got air coming in, and we're taking air out, and you've got diffusers. I mean, funny enough, my cousin who has retired, who you spoke to, he has one client left, and even though I mentioned we've done Paul McCartney's, I can't mention this client. They're very, very exclusive. And some stuff got put in there by an established AC company, but there's stratification going wrong, etc., etc. And my cousin will put that right. So the design is extremely important. Now, are you mainly looking at what we call mini split systems, or have you started to look at multi split and VRF and VRV type things?
I've looked at so out of my conversations with people, ducted is, if you can get it, people love it. So what duct, the difference between most people on here probably won't really know what ducted is. Most people listening. So if you think of it as the vents that blow warm air into your room, instead of having a what do we call these units? A wall-mounted cassette or wall-mounted box, just so people like know what we're on about.
Yeah.
Rather than having one of those mounted in your room, instead you have a vent that blows warm air into your room, and that is blowing from a central unit that's in your attic or something like that, or some other space.
Yeah.
Though people find those very comfortable, if you can find the right installer and you have roof space, they're cheaper or comparable in cost to the wall mounted units, and they're quieter. However, it's very difficult to find installers, and especially finding installers who will work in the residential space, putting those in, you know, £5,000 to heat, I don't know, 5 rooms, versus quoting you £28,000 because they're used to installing them in commercial places. Multi-splits, there are, for people who don't know, a mini split is a unit that has one outdoor heat pump bit and one indoor heating bit, or condenser in the case of heating, because the refrigerant will condense in it. A multi-split will have multiple indoor units for one outdoor condenser, not one outdoor heat pump bit. There are some weird quirks with multi-splits. So one of them is that because of the way these units are designed, the expansion valve for the refrigerant is on the liquid line. So what that means is when you're running one single unit inside, even if you have all the other units off, warm refrigerant will be delivered to all units. So you'll get a little bit of heat load across all the units, even though you've only got one on. And there is an efficiency penalty to doing that, because you've got warm refrigerant sitting in these pipes outside, and you've got warm refrigerant just sitting in unheated rooms. We don't know, or we don't have good numbers for what the efficiency loss is in doing that. But it's definitely something I want to try and quantify. So yeah, I've looked at quite a few different units. I think there's lots of interesting things coming over the next year or two. I know people talk about air-to-air, oh, it can't heat hot water. Well, you've got Medea who have made the Medea Circ, which is almost like a VRF system in that you can pull heat. So if you've got your unit in cooling mode, so you're cooling with the internal units, you can send that heat to your hot water tank. So you're not just blowing outside, which is pretty cool. And there's, I think, a similar unit from Higher coming out. I hope I said that right. And who else is doing it? Oh,
they could have got them. LG have got them.
Yeah, of course, they've got the Multi Plus. Yeah. So this, I think the heating hot water space with them is going to change quite quickly.
I just want to emphasize some great stuff you said there, Sue. You mentioned for people about how you can get a wall-mounted unit, or you can have basically grills in the ceiling that are inputting air, and they also have to extract it as well. And it's perfect for bungalows, perfect for bus. So my cousin who you spoke to, his daughter, he's got 3 daughters. One of them's got a bungalow. It's absolutely perfect. Now, of course, my cousin doesn't know what he's doing. I mean, if anyone's listening to this and wants to get interested and wants a consultant, my cousin, he's, like I say, he's retired, but he will consult. He was the first person in the UK when the Japanese invented all this. So when we talk about, so there's something called where we've talked about VRF and VRV, and what that meant was when these things got invented was usually on a multi-split system, all your units had to do the kind of same thing. So they were either in cooling mode or they were in heating mode. And then the Japanese invented where you could simultaneously do both. So you could have, and one of the reasons I think was in Japan, obviously in these really tall high skyscrapers, you'd have the sunrise, the solar would heat up that side of the building, so the apartments there would need heat removed, and they removed it to the backside apartments on the other side of the skyscrapers. so you could simultaneously cool and heat. And the Japanese came over from Mitsubishi and installed the first system in a hotel. There was another place they installed it, and then my cousin installed the first ever independent company to install the first ever system at Soho Square, where Paul McCartney's original offices were. And he did the VRV system for Dakin in Classic FM. They're very, very good if you get them right. You talked about linear valves. So the linear valves inside these things are very important. I mean, have you had manufacturers sort of getting, because I really value what you're doing. I really, because I don't think anyone else is, because it's such a commercial industry. People buy stuff, they go out and put it in. But people have it in their homes, but no one's really dug deep into, right, let's look into this. How efficient are these things? And that's you. Have you had any manufacturer? I know I hooked you up with some. Funny enough, I haven't hooked you up with Toshiba because they've been around a long time. Oh, and actually, while I'm talking about Toshiba, so you mentioned this thing about sizes. Now, air to water people, we've been talking about sizes for a long time. Where does that size come from? People think if you've got a heat loss of 10 kilowatt, you then go out and buy a 10 kilowatt machine. Well, it doesn't quite work like that. In air to air things, it's going to be even more complex for something because you can buy 2.5 Toshiba nominal rating. Well, that's going to be for cooling, and it's going to have a maximum heat capacity of around about 5.6, and it'll ramp down to about 0.7 kilowatts for heating. So it's going to interest lots of people, and like you say, there's not a lot of commercial AC engineers that are going to want to get into domestic for all sorts of reasons. So what I think is going to happen is a lot of heating engineers that are getting excited about learning stuff. They've learned all around air to water. They're going to want to go out and get their F-gas and put some of this kit in. And with mini splits, yeah, fair enough. I mean, they've got, like I said on my post, they've got to evacuate down them refrigeration lines really, really well. You don't need any moisture in them lines, otherwise you're going to be burning compressors out within about 5 years. But if you're going to be putting in your multi-splits and things like VRF systems, and like I say, bungalows, because you put the units up in the loft, and you can have some lovely little grills, whatever colour you want, etc. But you do kind of have to know what you're doing. Have any manufacturers are sort of like thought, oh, this is interesting, John. We're going to work with you and help you research some of this stuff. Have you found that yet?
Well, Hamill, I can't remember his second name, from Daikin, very kindly sent me over some
Oh, yes.
end loops from an air-to-air condenser.
That's it.
So that was very useful. I had chats with them. We might do something in the future, but they haven't got back to me yet. There might be a project with Nesta where we actually put one of these in the Salford house.
Oh, brilliant.
And actually sort of do all these tests.
Yeah.
Going back to the, but I'm always open to more manufacturers if they want to get involved and help do these tests, because I think we're in kind of this weird situation at the moment whereby we can put these units in and they work, right? They work really well for the most part, and it's the reason for that is because it's very difficult to get this wrong, right? Because you've got these internal units and each one can modulate its own power based on the heat loss in the room. So it can effectively vary the size of the radiator. So if you think of a normal air to water heat pump, what is challenging about those is not that they don't work well, they work really well. But what's challenging is that it's surprisingly easy to screw up the install by overcomplicating it, or making what we now know to be simple errors. With air to air, it's very difficult to do a bad install, to size it wrong and things like that, because there's so much modulation variation. You can put a unit in a room that's too big. You can install an outdoor unit that. So maybe I'll talk through an example of this. One of the people I interviewed, who's also got a YouTube channel, Tim and Kat's Green Walk, so people can go and see his and her experience there. I talked to Tim. He had a heat loss done, and when air-to-air installs tend to do heat loss they tend to just do it on the floor area of the house. So
Yeah.
they'll come in, they measure the floor area, and they'll say, right, do it on cooling load. That's 125 watts per square meter. So you can very easily oversize based on cooling load relative to air to water. So a good house in air to water, I think you might be looking about 40 watts per square meter, maybe less. I'm sure someone will correct me on that. So you've essentially got 3 times over that, because they're sizing for cooling loads. Now, I think that those sizing for cooling loads might even be excessive. So the unit I put in is a 3.5 kilowatt unit in a 60 square meter area, and I oversized it for the space. So I could have gone for the 2.5, but I chose the 3.5 because the room has a hole in the roof, which goes up to an uninsulated attic, which has been sort of boxed in. So there is a lot of extra heat loss. And I was sort of sizing it to anticipate the loft conversion, which hasn't happened.
Yeah.
But a lot of the units are oversized. Tim and Kat's case, the installers put in two Toshiba units. I think they're 8 kilowatt heat. And realistically, he only needed one. But what was potentially worse was that on one of the external units, it was a 2-port unit. Now, a 2-port heat pump means that you can drive 2 internal units off that heat pump. And the other one was a 3-port, so you could drive 3 internal units. If your load for your 2 internals is too low, so let's say you put them in, one's gone into a small study and one's gone into another room that's, I don't know, a hallway or something that's not used that much. That unit may never reach a point where it's actually working at capacity. So it was always going to be cycling, and that's going to be relatively inefficient. But also, it's just not going to be comfortable because the unit's turning on and off, so it's blowing hot and cold. You really want to have everything sized and everything organized for the load of the rooms in the house. And from talking to Daikin, I don't think there's yet good recommendations for installers on that. So it's down to the installer's knowledge and their experience. And in many cases, they are excellent and they do get it right. But in some cases, when they get it wrong, that's when you have this feedback loop where people suddenly say, oh, heat pumps don't work. Oh, I don't like heat pumps. So I feel like my role in this, or what I'm trying to do, is trying to head off these issues before it happens. So the market just keeps growing. People don't have this negative experience of air to air, which happened with air to water.
Yes. Yeah, no, I totally agree. I think, like I say, you're doing amazing work. This has kind of never been done before. So I'm going to be having a little bit of a theme around air to air because obviously, our good friend Andrew Sisson he put that post up, didn't he, saying it's going to be part of the bus. There's obviously conditions with that whole bus thing. I mean, I haven't dug into them yet. That's not my remit. I'm here to help people understand it. I mean, and as you know, there's some great people on LinkedIn like Michael Cosham I've had on here before. He's been installing stuff for a long time. You've got the lovely old gentleman, Bob and Bruce, I call them, and they're going to be coming on. It's very interesting for me to see how manufacturers are responding. So like you've just mentioned someone from Daikin, lovely, lovely guy. I interact with him. He's very, very supportive of what I do. I mean, Daikin is, well, it's probably a toss up between LG and Daikin, who is the largest in the world. I mean, it's kind of who now will dominate the African countries. I think Daikin have dominated India. I mean, because this stuff is literally everywhere, everywhere. Now, we have been quite slow to go into the domestic market for obvious reasons. We built one of the most extensive gas grids in Europe, us and the Netherlands. Other countries can do it. So Scandinavian countries are large archipelagos, some of the largest in the world. You can't keep laying gas pipes underwater. So they went oil. My grandfather helped them develop that. And they went quickly to heat pumps. And they became arguably sort of the leaders in air to water heat pumps. Now, interestingly, they are all switching. So a lot of the heat pumps now going into Finland and Sweden are air to air stuff. So it can work because these are cold countries. it's going to be interesting for me also from the engineering perspective. We've got this, and that's why I've started up the Guild of Master Heat Engineers. We have got engineers out there who are so super interested in learning, like people like yourself, and they are going to want to get it right. They're going to want to get that. We're going to obviously have that cowboy element that's just going to go around making money, chucking stuff in, but we're going to have some engineers that are going to get really into the roots of this and the weeds of this, and really and engage with people like yourself to see what the most optimum ways of doing things are in someone's home. So it's quite an exciting, because we are all used to this. I know we're not all used to heat pumps attached to wet systems and radiators, but we are all used to radiators. We really are. And so I think there's going to be a real big passion. And I made a bit of a call. I'm wrong a lot of the times, but I said, maybe in 5-6 years' time, air to air will supersede air to water heat pumps in this country, because like I say, we've got the largest commercial market in Europe. We've seen the Scandinavian countries kind of switch to air to air. I don't know what are your thoughts on that?
I think yeah, I think you could be right in some respects, but the way I see it is that at the moment everyone is looking at it air to air or air to water or air to air versus air to water. I see them as complementary technologies. I think they work well together. I think what is missing is the controls. So at the moment, if you install an air-to-air system and an air-to-water system, what you have is two independent systems that are choosing how much heat to put into your house based on their own internal control logic. If you fix that and you close the loop, then you have two systems that are working together and minimizing flow temperatures in radiators, minimizing refrigerant temperatures in the air-to-air unit, and therefore you are getting a higher efficiency, but you're also having the benefits of air-to-air. So you have cooling, you have very fast heat up if you need it. I think there might be this space where there's actually a crossover for a lot of people, because more people will install air-to-air over time for cooling. If you can make that work with air-to-water, that's a huge benefit. But also, maybe you're right. Maybe air-to-air will dominate because people do want the cooling. At the moment, most of the units are primarily designed for cooling rather than heating. We are going to see that change over the next few years. Manufacturers will release new products which are more optimized towards heating. I would say that if people are looking for one product that interests me is but I've not seen it in person, I want to caveat that, the Daikin Performer low wall mounted unit. So it's kind of like a radiator. It's low down on the wall. But what it does is it blows air down and across the floor, but also upwards, which is useful because you don't have to fight against the stratification of the air by blowing air down from a high wall mounted unit. So in theory, it should be quieter and things like that. But I don't know. Haven't seen it in person. Haven't experienced it. I think we'll see some innovative products, and I know there are quite a few installers who I spoke to who are quite concerned that everything was going to move to propane, and there wouldn't be any low GWP refrigerants. From my conversations with manufacturers, that won't be the case. There will still be refrigerant-based systems with low GWP, so below 150, and those will continue up to at least 2030. So the refrigerant things aren't going away with the GWP rules.
It's very another interesting thing I want to mention. So we seem to have this. I know we're all trying to decarbonise, and but there's this mindset that a heating system in someone's home is just one type of system. Now, we've had all sorts of systems, and some people sometimes have all sorts of systems in their home. I mean, there's people with gas boiler heating that still plug an electric radiator in some type. We've got lots of different heating devices, and some people do switch and match. Now, I grew up in rural England in Norfolk, and I was chatting to Offtech the other day because I noticed they reposted my local MP, Ben. He was basically saying rural properties can't be, it's difficult to heat them with heat pumps. And I'm going to push back that. I really respect Offtech. My granddad wrote their first ever standards, but it's actually quite easy. I know a lot of farmers. Now, these farmers haven't been buying air to water. Some of them aren't that interested. These people that are living in these detached homes, they've got lots of garden space. Now, you can actually go into one of them homes, and for the price of a premium boiler, I can buy 4 mini splits, and you can put 2 downstairs, you can put 2 upstairs. And what they will tend to do, though, they'll want to keep their oil boiler still as a backup. And oil is a backup in so many critical places around this country. We have diesel backup generators everywhere. So I think there's a mindset that if you have a new heat system, you have to take everything out. Now, obviously, for the grant system, that's obviously what's kind of going on. But you will get, it's like in Sweden, the Swedish and the Finnish will say it's for aesthetic reasons. And I mean, Norway, I think, is still the biggest market for log burners on the planet.
Can I
And
can I
why
jump
not?
in?
Yeah.
So with regard to the heating thing, there is a quirk in all heat loss calculations which hasn't really been addressed. Heat loss calculations are steady state, which means that it assumes that heat doesn't rise or move around the property. You have like these calculations that sort of, it will pulse and things like that. But heat does rise. We know it rises, which means that you can put a powerful unit in the down, say you've got a big house, where you've got a house with a hallway and you've got a staircase and it needs to flow upstairs. You can put a powerful air-to-air unit in the downstairs space and it will heat that whole space and it will spread because hot air rises. And I do think you're right, actually, in the idea of using air-to-air to decarbonize, or it's not even just decarbonizing, it's just improving. And I think this is something that's it's something that's lost for me, right? People constantly talk about, oh, we've got to decarbonize heat, we've got to decarbonize that. Like, well, you've got, I don't know, what percentage of the population who don't care about that? So why don't you say, well, we can just improve your heating system and make it run for less? And they'll say, what? Well, no, that sounds like a much better value proposition. So, for example, my mum has what's called an alpha, which is kind of like an Arga, but instead of having burners, so Argas have burners that burn constantly at a relatively low rate. These have 2 40-kilowatt oil burners, and they are like jets, and they can't modulate. And this is a big cast iron sort of range thing. So when this comes on, it's using a lot of oil. It is connected to a vented hot water system, and it has to have a heat leak radiator on it. So their instructions say you must install a heat leak radiator. That is ridiculously inefficient. It's not condensing in any way. I think I worked out from their gas usage and not gas usage, oil usage, and from how cold the house is, that it must be less than 50% efficient. The heat geek actually came around and they did a heat loss calculation of the house and worked out to be about 12 kilowatt, which I had done back of envelope calculations, worked out the same thing. So it's sort of demonstrating that this old system is rubbish. So what a lot of people are doing when they're doing their sort of what's my ROI or what's my payback, they're looking at an inefficient system, but they're modeling it like it's an efficient one. So if you say, oh, well, oil prices, I don't know what it is at the moment, let's say 70p per litre for heating oil. They're saying, well, I use this much oil and that has this much energy in it, and I think my thing is this efficient. Therefore, electricity is this much, and I won't get a payback or whatever. They're not looking at it saying, oh, actually, my current system is terrible. And actually, if I just install an air-to-air system, it will pay back very quickly and be more comfortable. But what I was going to sort of get at with this is, I think properties like my mum's house are ideal for air-to-air systems. I think that, knowing her house very well, I think that you could heat most of the house with 2 units because it's got so much thermal mass. I think I worked it out, and you're talking about 200 ton. No, I think it was like I can't remember. It was a lot of limestone and it would absorb a lot of heat.
Mm.
And with air to air, you can run it on your overnight tariffs. You can absolutely blast the heat in. You can use the house as a thermal store and make it more comfortable. Now, as I said earlier, like there are lots of people on LinkedIn and things like that who say, no, you just want to heat the air with air to air. But I fundamentally disagree with that approach. I think that for some people in fuel poverty, that approach might make sense, but I'm still not sure if it does make sense yet because we don't have good efficiency figures on running these units intermittently. And I do know that from my own monitoring that the internal logic of these units is very poor when it comes to running intermittently. And this is actually prevalent across air to water heat pumps too. So if you look at an air to water heat pump or an air to air heat, so if you look at an air to water heat pump on heat pump monitor, generally what you will see is if there's a large temperature difference between the target hot water temperature and the current hot water temperature, it will spike the compressor and it will like absolutely ramp up the compressor to sort of its near maximum value or a high value. Compressors on these units are less efficient when they're at very high values or very low values in general. So you've got that little peak when you're returning from setback, which is inherently inefficient, or that little peak, which is often from when the internal thermostat is saying, calling for power again. And there are little steps like this, which you could add the logic to these systems and improve the efficiency. And you can document, there's documentation of this with Mick Wall, your favorite homeowner, who has obviously talked about his eco mode on his Valent a lot. Glyn Hudson's done the same, talks about his eco mode on his new grant and quantifies the efficiency gain from using it. So what I was getting at with that is with air to air, you have the same issue where you use it intermittently, it is chasing this temperature difference. And in doing so, it ramps up very high and uses a lot of power. So I've had manufacturers tell me, well, that's how we want it because we want people to be comfortable immediately. But there's no choice for the homeowner whether or not they want to be comfortable immediately or whether they want to be comfortable efficiently. And I think that's something that needs to work into all of this. And that needs to work with better controls and optimization for overnight tariffs. And just generally improving the controls of these systems, which will happen over the next year or so. But at the moment, I just feel they're a bit hit and miss sometimes. Gone off on a tangent.
That was brilliant, John. Brilliant. I mean, it's so super interesting, isn't it? I mean, you're right. So there's going to be a lot of people that spend a lot of time, for instance, in the same room. You know, like I say, my dad retired at 76. He's 81 now, bless him. A lot of his customers are actually old enough to be his parents. You know, they get up and then they spend their time in the same room, and you could have one unit in that room. Yes, they've still maybe got their oil heating somewhere, maybe doing their hot water. But you know, if we wanted to decarb, let's say someone said, right, we need to decarbonise the world now. We've got 10 days left, otherwise the world stops. You wouldn't go out and design air to water systems. You'd go out and you'd stick these things in everywhere because, like I say, people can sit in that one room. They've got this one. It's decarbonising. You still got your oil boiler there somewhere, but so I think the good thing is what you're doing is, you know, this is all stuff we don't know. These are all unknowns. We know what kind of works in commercial, and a lot of it doesn't work. I mean, a very famous musician's actually just died. I mean, I don't know if you're into your music, John, but Gary from.
I used to play the recorder in primary school, so.
Well, you know, people have been saying when I've been talking to air, you know, they say all the time, oh, don't work in old buildings. You've got to have new buildings for heat pumps. And I say, well, I've pulled them up to a church roof. I think he broke my ribs doing it. And I remember putting that inside unit indoors and seeing one of the master tapes for Primal Scream. You know, some of the Donna's recorded, everyone's recorded there. You know, these things do work. They're in churches. Michael Cosham is putting them into churches everywhere. So I just want to re-emphasise, people are really, really worried about insulation. You know, trust me, insulation, yes, you want to reduce your heat loss, but reduce it sensibly. And we've got this strange thing going on in the country where people, why haven't they actually thought, well, insulate before you put a boiler in? Heat's heat. The laws of thermodynamics aren't actually thinking, distinguishing between what technology you got. Heat's heat, it moves out of the home.
I
And
think we're at a crossover point at the moment where insulation is probably not the best option. I think that's not just due to the heating systems, but also due to the absolute collapse in the price of batteries. So there's a Fogstar battery. You can only pre-order it at the moment. It uses LFP cells, so the cells you find in your cheaper Chinese EVs, which are actually better in a way because they can't do thermal runaway. So I think I saw earlier a 16 kilowatt battery for £1,600. Now, you're not going to get, unless you're just laying fiberglass insulation or rock wool in your loft, you're not getting a lot for £1,600. So it's very much coming to the point where, well, maybe I should just buy a couple of batteries and get all my cheap electricity overnight. And I think that in combination with air to air is very compelling. I think that in combination with air to water is very compelling.
I mean, if you've got the money, you can insulate your home really, really well. Yeah, go and do it. Makes sense that. But as we know, it's not being done well. A lot of places where I've grown up around, they're vapor open buildings where you need to understand moisture migration and stuff like this, and you just whack external water, which is going on. The eco people. Oh, didn't you? Was it you? You watched the budget, haven't you? Has eco stopped or something? Then I don't know what's going on.
Eco is dead. Probably a good thing. I wonder if it's worth sort of just talking about some of the homes. So I've interviewed people for this. Yes. We talk about like some of the homes that people have installed them into.
We can get them on at some point as well, John.
Yeah, I mean, some of them would love to come on, and actually, they're very, very knowledgeable. So the people who have installed these aren't people who have just gone, oh, I'm just going to install air to air. They've mostly exhausted other options, or like air to air has become the logical approach because of some other reason. So I've seen them in Highland houses in Scotland, not just Ez's, but another one, sort of Edwardian houses, sort of, I suppose that's I've only given 3 examples there, but there are basically every house archetype you have, they have installed them in. And what's interesting is they work in all of them. Now, I would caveat that with, because you're doing air to air, there are certain properties that are a bit more difficult to install in. So if you've got a terrace house and you're only going to have one external unit, then you've got to run pipes all the way through the house. And your 2 choices are put them under the floor, which is what you do with heating, or you run trunking all through the house, which is not very pretty. The other issue you have with some air-to-air units is you do have to run trunking up the side of your walls on the outside of your house. Now, some of this trunking is not particularly pretty, and I've been told by Ian Mather at Robert Heath that some of it isn't UV rated. So you can install this trunking, and in a few years it will start breaking down. And it's the same thing with insulation, actually. So the insulation that both wraps air-to-water heat pump pipes, but also air-to-air pipes, if that isn't UV rated and it is exposed to the sun, it will break down, and then you have to replace it, which is a pain. But yeah, lots of different houses installing. They work everywhere because it's like an air-to-water heat pump. All you're doing is you're adding heat. If you add enough heat to a building, it will get warm. If you have a low enough condensing temperature in these, it will be efficient. Just like if you have a low enough flow temperature in air to water, it will be efficient, with a few caveats.
Ooh, let's talk
just one sort of tangential thing that came up from installers and homeowners was that these units the cooling function is great, and especially great if you're going through menopause. So a lot of women suffer from hot flushes and things like that, and they find general life to be quite stressful at that point. Lovely if you can just turn your heating system into a cooling system and go and sit in a cold room. But there's added value propositions to air to air that don't really exist with air to water at the moment.
Mm. Well, I've seen some people challenge me on that. Air to water, air to water can do cooling, we know that. But air to air is removing heat. That's kind of what most people have been putting it in. You're removing heat removal, which we colloquially call cooling. Now, I wanted to. You kind of started on your journey. I think you wanted to measure efficiency. So, how have you been getting on with that? What's sort of been going on in that sort of area?
So it's been a relatively fun game. So initially, the straightforward approach was to do the mass flow measurements and look at the temperature before and after, and the volumetric flow, and the sort of heat delivered to the air, and therefore work out COP from that. I need to revisit that because obviously it's winter now, and automate it so it just outputs that value all the time. Because I've got open energy monitoring kit, I just need to write the equation to sort it out. But the unit I installed, I think I worked out it had a COP of around 4 in February last year. Now, this method, it works, but there are some caveats with it. I don't have an anometer, so I haven't been able to verify the manufacturer's flow measurements for air through the unit. I've had to just say, okay, I'm going to trust you on this, and I'm going to have to interpolate between these values. Now, people might be wondering, how do I know the velocity at the airspeed at any time, or the flow? What I've got a CT sensor, so a little sensor that measures electricity on the internal unit and on the external unit. And what I did is I sat down with the unit and I went through each fan speed. And I said, okay, at fan speed 0, it's using this many watts. Advanced fan speed 1, it's using this many. Fan speed 2, it's using this many. And then I used that against the manufacturer's values of how much air it was putting out at each fan speed to sort of gain the mass flow through the unit. And once you have the air above and the air below, the air temperature above and the air temperature below, you can work out the temperature gained across it for a volume, and then through that you can sort of estimate the COP. Now, I would caveat this with that my unit is a particularly good unit, and I've subsequently found out why, and it's because of the compressor in it, right? Most of these, so I've got a dual compressor in there, so it's a dual rotary compressor. What it is kind of irrelevant, but it's incidental that it has a very low minimum operating range, so it can go down to 10 hertz. Most of them, you're looking at 25 hertz minimum. I understand the Daikin's can go down to 10, but they don't always go down to 10. Maybe the LGs do the dual rotary compressors. Maybe those go down to 10. But the compressor in this unit is made by Sian something company in Thailand, and it can go down very low, but it also has a very low stroke volume. The amount of compression refrigerant it moves in each compression cycle is very low. So it can tick down to 100 watts and just tick over very lightly. And in doing so, that's just very efficient for the heat moved and the power used. Some units don't have this level of efficiency. Their minimum power output is, say, 260 watts or even 400 watts for a 3.5 kilowatt unit. I've seen that. I don't know, but I strongly suspect that those units at lower loads will be considerably less efficient. Whether or not that affects the overall SCOP and COP of the unit, again, is one of these questions that I don't properly know. And no one's got any good data on this yet. Because obviously, if you're in your shoulder months and the heat load required in a room is less and it's cycling on and off a bit more, you're using less power as it is. So the proportion of electricity used at those times of year is actually considerably less. I think Mick Wall's actually done something on this for his air to water unit that he put up the other day. I've not read it yet, but I saw a graph. But basically, he was showing that at certain times of year, you'll use a lot more electricity and you'll get much less heat. and those are the times of year that will swing your SCOP calculation rather than the the efficient time.
Mm.
So my current goal has been to build something more generic, which anyone can install on their own mini split and estimate the COP by doing the Carnot COP. So this is directly lifted from John Cantor, who sort of did this on his unit. He's got a no, it's a super cheap one, Electric Q, the propane unit. So he's got very cheap £700 unit, and he has he brazed a couple of copper pockets onto this unit, and he measures the condensing temperature, and he measures condensing temperature on the inside unit and the evaporating temperature on the outside unit. And from that, he can work out the Carnot COP, which is, you know, your hot measurement divided by your hot measurement minus the cold measurement in simple terms. And that's going to give you your Carnot, and then you sort of divide it by 50%, maybe a bit more, to get your actual true COP out of it. And that 50% is coming from measurements from Heat Pump Monitor. So because Heat Pump Monitor know the Carnot COP of their units, or can very sort of pretty precisely approximate it, you can sort of say, okay, well, if this air to water is, or if the fleet of air to water are on average this Carnot COP, then this air to air at these conditions will likely be similar. So
I'm glad you mentioned John Cantor, because obviously he works closely with them two wonderful gentlemen, Trystan and Glyn, and he's been such a great asset to this industry. That's what I was going to ask. So you're using the Open Energy Monitor stuff. Now, some people that use the Open Energy Monitor stuff, other people can see what's going on the system. Is yours sort of open source, or people can see?
Yeah, so it's published on a little dashboard, so people can look at the dashboard. But the dashboard requires me to, I'll send a link over to you, and you can pop it on the show notes or something like that. But the dashboard requires me to make the graphs and things like that, and I've not made them that well currently. But I can improve upon it. There's also a sort of caveat with some of the measurements on my system. I need to make it, I'll have to ask Trystan and Glyn about this. Can it appear on the Heat Pump Monitor in like some other way? Or I think I can just give out the API details and people can just download it if they want to. But because I'm iterating on it quite regularly, there are certain sensors that are changing. So I think you saw my blog post where I'd started with sort of wrapping these copper pipes, these 8mm copper pipes, to the condenser and to the and sort of using it as a little pocket for a temperature sensor to sit in. And now I've iterated over time to sort of trying to cast some little tin sensor mounts. And the tin sensor mounts are now working better, but the castings I made are slightly the wrong size, because it turns out the Daikin end loops that I got sent are a different dimension to the, I suppose I'm saying end loops to people, and they're not going to know what I'm talking about. Basically, there are these small little curved copper pipes that are inside your internal heat pump, internal unit, that I'm trying to attach a temperature sensor to and trying to take a temperature reading off of. And it's a very confined space, and I can't braze them on or solder them on because it's full of refrigerant, and I don't really want to chance it. But also they're surrounded by plastic, so there are levels to this, which just makes it more difficult. I'm trying to create something that people at home will be able to do. So if you get one of these units, what's the minimum amount of effort you can have to have a little system that sort of approximates to a relatively high degree of accuracy your COP? And I think once I get this right, I might be able to get a load of little brackets CNC'd. I'll have to see how much they cost. If they don't cost too much to CNC, then we might be able to put together a little measurement thing that people can take, who can buy from Open Energy Monitor or something like that, and take their own readings.
That's fascinating. Well, John, it's been an absolute pleasure chatting to you. This is we've had some air to air episodes before. I've had Michael on, I've had Bob Beattie on, but I think this is sort of going to engender a real fascinating um, sort of chapter. I think because obviously we've all and like we've both said, air to water is fantastic. It's very very comfortable. Obviously it has to be designed right. Um, but air to air now people are starting to become more aware about. It's as we all know, we all say it. I mean, it's all bespoke. It's bespoke to the home type and who's living in it, etc., etc. But it's great that people are now really, really sort of digging into this. And what I think you're doing is fantastic. I'm going to hook you up with some people that I know that are very good with Toshiba units because they might be interested in helping you. Because I think if the manufacturers help, I mean, it's interesting with manufacturers. I mean, these are super, super big manufacturers. I mean, so it might be. I mean, we're a tiny, tiny little market. A domestic air to air, for instance, is extremely tiny for someone like Dakin. Um, but we might find some other sort of bit tinier, smaller manufacturers that think, oh, let's really get into this kind of market and help people like John and Nesta and John and Glyn. Because I think the more we know and the more we can research this stuff, it's fantastic. You're going to be in the well, if you can get into the energy house. I think they're building a new one, aren't they? That's a bit more realistic than the Energy House 2 because they've got such low heat transfer coefficients. It's kind of not real world testing, maybe. But
Yeah, I think the interesting thing with a lot of this is that the possibility to do lots of testing and find these things out isn't particularly expensive.
no,
So you can install a high-end mini split. So if you want a like top of the range, uh, let's say 3.5 kilowatt output mini split, £2,600, you'll probably easily get that installed. If you want a low end one, you're talking about £1,400. I think that generally I would always sway towards the higher end units, and I'd tend to look for ones which are compatible with an external thermometer, temperature sensor or thermometer. One thing I do want to sort of point out is that there people should be aware that if you use them for cooling a lot, I, I don't think we really have this problem in the United Kingdom, but if you use them for cooling a lot, and you'll see this on American units, what you have is you have the fan on these internal units. If the fan is after the internal heat exchanger, it'll be cooled below the dew point. And when it's cooled below the dew point, it gets moist.
yeah,
And what can happen over time is dust can build up on it. And if dust builds up on it, mold can also build up on it. And the cost of cleaning and maintaining some, not all, but some of these internal units can be quite high. And some units are more prone to this than others. So that I think it's important for people to be aware that there are potential maintenance issues or considerations rather than issues, which you don't have with a wet heating system because you don't have to have someone come over to spray your wet system with biocide. But also your wet system can't cool. So, swings and roundabouts really, isn't it?
well, that's a whole different episode. Condensate control because obviously some of these internal units, you have to get rid of the condensate. You've got things, different types of pumps sometimes, and sometimes these pumps have float operated sensors that sometimes stick.
Yeah, they can gum up.
The
Yeah.
sludge at the bottom. Some are very, very. I don't know whether I should mention them, but they're very, very high up in the heat pump world in Europe. They're a keynote speaker today. That they're going to be chatting to my cousin about some stuff because they've just moved into a place which is all heated with this kind of stuff. Because a lot of a lot of European or a lot of our apartments still heated and cooled with this stuff.
Yeah.
But it can go in wrong, unfortunately, and you got leaks. So yeah, I mean that's a whole new episode. I'll get the whole condensate thing. People are going to think that maybe they're going to probably associate that to defrost. So I don't know, but yeah, the internal units. There's an issue sometimes, but it's just down to maintenance and it's just down to design. If you get it right, not a problem.
Yeah, exactly. It is down to that, but it's just something that is
Oh yeah,
it's one of these ones. As with air to water, if someone has a big surprise, then it makes them like the system less, doesn't it? And they complain about it. So with air to water, I guess one of those with that is, what's your manufacturer's guarantee for many of these units? It's only valid if you're having it serviced yearly, and that servicing cost is going to cost you £300. So, and if someone doesn't service their gas boiler at all, or service their those costs are significant, or if they are having it serviced, it's probably less than that. But as someone pointed out to me, a gas boiler service and a heat pump service is very different. You're actually doing something with a heat pump service rather than a gas boiler service. You're kind of just walking up and going, yep. So it's more about letting people know that, look, if you get one of these units, then you might, if you use it for cooling a lot and under certain conditions, it might require cleaning. It might not. This is another sort of grey area in the UK. Most installers offer internal unit cleaning. It costs about, or servicing, you're talking like £100 to £200 for the external unit, plus £50 for every internal unit. They're all very transparent on their pricing. So you can literally ring up an installer and say, right, how much is my servicing going to cost based on this? So you can sort it all out before you install it. But as I was saying, one of the key things about, if people are going to go to air, and we are going to say, oh yeah, this is good for heating, is know, right, what are the issues down the line? How do you mitigate them? How do you make sure people are aware of things? And before you go, one other final point that occurred to me the other day is, we have currently no idea how many air-to-air units are installed in the UK and could be used for heating and aren't. It could far exceed the amount of air-to-water units that are installed. But apparently, one common theme with installers is they will install an air-to-air unit, and they'll say to the homeowner, "Oh, it can heat as well," and they're like, "What?" Yeah. So they don't install an air-to-air unit; they're installing an air conditioner for someone because the person wants cooling. But they'll say, "Oh, your cooling air conditioner can heat as well," and the vast majority of people are surprised. They have no idea their cooling unit can heat, and it's got an efficiency which is comparable or better than the gas boiler in terms of cost.
No, you're exactly right. I mean, I remember walking down the street in London, and there must have been 30 houses all in a row with all this stuff, and that they're just, you kind of know they're just going to be using that unit. It'll be just one unit in a room, particular room, and it's just going to be used for cooling, because they're not told, or they don't know. Don't get me started on servicing. The gas industry, that isn't, most of the servicing going on is not a service, it's a safety check. So all these companies a few years ago realised there's money in this. Your home trees, your home serves, your BG, people are paying their monthly fees. That engineer that comes around, and what you think you're getting a service, you're not. You're getting a safety check. They put that flue gas analyzer in, make sure everything's safe. They do a couple of visual checks. That's it. Off they go. They aren't servicing, cleaning stuff down, checking pressures on, let's see, expansion vessels and things like that. Very, very lucrative industry. Now with this stuff, you got to proper service it. So that's going to be interesting as we progress, because obviously there is a cost to servicing when you do something properly. But don't get me started on that. John, thank you ever so much. I'm going to get them links off you, because I want to get the link to that couple with the YouTube video. I think that's going to be helpful for people to have a little watch.
So I'll give you a good few links. There's lots of people. There's Tim Mortimer on X, Jimmy DB on X, Tim and Kat's Green Walk. If you want a different perspective for air-to-air heat pumps, we can do the EV guy, and that can be when something goes wrong.
Right.
Their system, they were unlucky. Their system sort of went wrong because they had an extension while they were installing the unit, and they forgot to. They sized it for not the extension rather than. So they didn't size it for the future load, they sized it for the current load, which caused some issues, and this placement of the unit. So the key thing is, don't have it, if you're sitting somewhere, you might like it blowing on you and warming you up. You might be one of those people, but most people prefer it not to be blowing on them.
Mm.
So if you've got a table or something like that, you don't want it blowing down on the table. You want it somewhere a bit more innocuous.
No.
So we'll put in some less brilliant examples too, because balance, isn't it, and learning.
Yeah, people will see what the potential issues are they've got to avoid.
Yeah, exactly.
Because you've got, like you say, you've got another consideration. You've got air movement to consider. With a wet system, no one's considering the air movement, but with these you have. John, fantastic. We're going to be getting you on soon, I'm sure. It's been a pleasure to record you on this day, this eponymous day. Is that the right word? Heat Pump Association conference going on, and obviously we've had the budget. John, thank you ever so much.
Thank you very much, Nathan.